Today we're looking at items for sale. The school has $35,000 to spend on new desktop computers. So the desktop computer is what we're looking at. How many computers can they buy? I want us to think how we might use a ratio table for this. We want $1,499.99, and how many of those will add up to be 35,000? What's some ideas you have around being efficient with this calculation? I do not want to do some standard algorithms. That is not efficient, fast, and easy. So pause the video and talk about what might be some tips to think about how to make the calculations more efficient. Discuss now. Okay, let's share some of these things. I'm noticing that this number is 1 cent away from $1,500. That is a much easier number to work with. So one thing we might do is just use this amount to figure out what might be closest to 35,000. That will be my first step. Did you talk about that? My next step, I'm thinking with this table, if one of these is 1,500, I want to know how many can I get close to 35,000. So I want you to do something in how you might think through using this ratio table to get to that number. We do not want to use standard algorithm. We are not going to divide and figure all of that out today. We're going to use some more efficient thinking. So pause the video and give it a go using the ratio table. Pause now. Okay, there's so many ways we can think about this, making it efficient, fast, and easy for us. I think I'm going to just start with 2 from work backward. So I know that 1 is about 1,500, so 2 will be 3,000. That's an easy number to work with. Then I think, I bet we could probably fit 20. And 2 times 10 is 20. So that would be an easy jump. So I'm thinking 2 times 10 is 20. So 3,000 times 10 would be 30,000. Okay. That's getting pretty close to 3,500. So I know I can fit at least 20. That gives me a big jump. But I think I'm gonna have to go backwards a little bit. I'm wondering now, 2 was 3,000. How much would 4 of them be? 2 times 2 is 4. So 3,000 times 2 is 6,000. But if I put these together, that's too much. So it can't be 20 and 4. What are you thinking now? What might be my next step? Pause and have a talk. Okay, I'm kind of thinking maybe 3 will work. 2 is only 30,000 and 3,000, 33,000. And I have a bit more. So if I did 3, 1 and 2 is 3,000 and 1,500. That's 4,500. What can I put together now? I notice that 20 is 30,000 and 3 is 4,500. If I put these together, it would be 34,500. That's less than 3,500. And that'd be 20 and 3. So if I think about it, 23 of them won't be 35,000, but it will be 34,500, and that's only 500 away from 35,000. So I think that they can buy up to 23 laptops. 24 is going to be too much. They don't have enough money. What do you think? What did you get with your ratio table, and how does it compare to my thinking? It probably won't be the same. So have a talk about what was the same and what was different. And what do you think is efficient thinking now? Pause now. Okay, let's do some checking of our work. We've been working on estimating to check. So now I'm wondering, this 23 computers times that 1,500, it should be that 34,500. That's one way I could check. I could do the 1,500 times the 23 and check that way. That'd be a pretty efficient check. What's another way I could possibly check? I could even divide it. I could say 20 times 1,500 and 3 times 1,500. Hey, which I've already done some work over here. That's so easy. I can connect that to that, and putting those together might be a way to check. What's another way I can check with estimating, not doing an exact number? I do not want to do this $1,499.99. That is too complex. Make it easier for ourselves. Go ahead and pause the video now and decide how you might check with estimating. I thought of two more ways. I could take that 35,000 and divide it by 23 and see if I get the 1,500. Or I could take the 35,000 and divide it by the 1,500 and see if I get the 23. Which way did you check? Work together as a class to see if that number that you got was close to what we were aiming for, and are we accurate? Finish it with that discussion.